Welcome to episode 18 of the Interview with Scientists series. Our guest for today is none other than Dillion Jones. Dillion is a biologist and science communicator who deconstructs evolutionary theory into stories of natural world. Currently, he is completing his master's degree in evolutionary biology at San Diego State University. Today, we will talk with Dillion about his work in Belize, big data sets, biogeography, and effective science.com. Welcome, Dillion, and thank you for joining us today.
Yeah, thanks for having me.
Our pleasure. So, as you are currently doing your master's in evolutionary biology, can you tell us more about this field of science and what piqued your interest in studying evolution?
Yeah, I mean that's a really great question because my background is really ecology focused, so like
Okay.
going out and figuring out where species are, or,
Yes.
like what they're doing. But I switched to evolutionary biology because it sort of tells these like really incredible stories of how species became species, or
Okay.
how are they distributed where they are. So I got into this field to really sort of uncover the stories of how biology works on the planet.
I
So
see.
that's really what got me into it.
Interesting. So, can you tell us some fun facts or interesting facts in evolutionary biology?
Oh gosh, yeah, I can go down to some really deep rabbit holes, because what really gets me is like a lot of the theory behind it, right?
Yeah.
Like when we speak about evolutionary forces, we often talk about, I mean, natural selection is like the one that everyone sort of, I think, intuitively
Yes.
knows. But there's also things like genetic drift. There's of course like mutation. I guess drift is basically randomness. You know,
Yes.
it's just random things happening, but it informs so much about our uh, biology, about how well animals are, where they're at, or plants, or
Yes.
anything that lives.
Yes.
Um, and so the one I always go to is Belize salamanders, because I just think they're such a fascinating group. But they have these incredible like feet that are these like suction cup looking things,
Yes.
because they allows them to climb trees and climb stuff. But it's this really interesting story about dispersal from what is now the continental United States down through Central America, getting into South America.
Okay.
And as temperatures got a little bit warmer, this is sort of one of the theories. As temperatures got warmer, they started to develop faster and faster, developing to this point where their digits just didn't separate. So now they have these club feet that access suction cups. So they're kind of like Mission Impossible salamanders. They're so cool. They're so
Okay.
cool to me.
That's interesting. So, yeah, as you mentioned, like when people think about evolution, they just go to Charles Darwin theory of evolution, the origins of life. So, as we are talking about Charles Darwin, can you briefly explain what is this theory that he proposed, origin of life?
Yeah, yeah. So there's I mean the theory of natural selection. It's
Yeah.
sort of what's focused. It's sort of what like a lot of evolution has really focused on for a long time, and I think because it's such a cool idea, you know, like
Yes.
survival of the fittest. And at its core, it's saying that there are, within a population of some species, there are certain traits that are more beneficial than other traits, and
Yes.
those traits are selected for. So they are essentially passed on to the next generation, so
Yeah.
that that next generation has more of these beneficial traits.
Okay.
And it gets into some really crazy stuff, like the deeper and deeper you dive into it.
Yes.
Which is what I love. I just think it's so cool to think about that. But yeah,
Yes.
like as like a super surface level, that's what natural selection really deals with.
Okay. So, what are some of the career options as an evolutionary biologist?
The career options is
Yeah.
what you said.
Yeah.
Yeah, yeah. So there's a lot, because evolution is like one field, but it diverges into so many different subfields.
Yes.
I think what a lot of people end up going into is the population genetics,
Mm-hmm.
which is so critical for conservation work. If you're working on any type of like threatened or endangered species, say for a government organization or a nonprofit, or
Yeah.
even at a university, you're likely going to be working with population genetics, just
Okay.
saying, how diverse is this population? Is it sustainable? Does it need better genetics? Does it need maybe to have some species mate with, or some individuals to mate with other individuals?
Yes.
So I kind of touched on that, like non-government organizations, but also government organizations, and also just staying in academia and doing research. There's a lot of different options.
I see. Great. So, why were you in Belize, and what were you doing there? It's interesting to
Yeah.
know about it.
Yeah, so I lived in Belize for it was a total of about 9 months,
Okay.
and we were at the Toucan Ridge Ecology and Education Society. It's this research station right in the heart of the Mayan Mountains,
Yeah.
and a big part of what I was doing there was this radio telemetry study with these mud turtles.
Yes.
Basically, it's a big antenna that it's like a metal detector for turtles. It just points and beeps and says, "Hey, the turtles are this way. Go that way."
Okay.
Um, yeah, but we were basically tracking them, and I mean that was like the main project, but there were so many side projects. I was managing a few interns. I was helping with just some of the education material.
I
So
see.
I love it there. It's like my second home.
Okay. So, why were you tracking the turtles? Any reason?
Yeah, so it's interesting because with this species, it's white-lipped mud turtles, this
Okay.
Kenastern and Leucostomum. They are they are really variable across their range. So a lot of species live in lakes or ponds or whatnot, and they may eat only, they're maybe mainly carnivorous, but then you go to a different population and they
Yes.
live in streams and they eat only plant material or
Yeah.
something like that. It's always different. So we realized there wasn't a, or not we, but like the station,
Mm-hmm.
because they started the project before I was even on
Yeah.
it. They realized that there really weren't any studies looking at this species in these really dynamic river systems that are
Okay.
prone to massive floods and changing conditions constantly.
Yes.
So we wanted to figure out how are these turtles distributed in this ecosystem? How are they moving over time? Do they have differences in the wet season and the dry season? Do females do something different than males? And yeah, it's a super interesting project. I think total now they've been tracking them for 6 years.
Okay.
Just every year another set of like 10 to 15 turtles.
I see. That's really interesting. So, what were some of your findings regarding this?
Yeah, so some of the preliminary findings were really interesting, and it's like I love it. So um, males had more average movement.
Okay.
So we were always measuring, where did they go, where did they come from, just with GPS points,
Yeah.
and we found that males on average they moved more often, but their home ranges, so where they actually
Mm-hmm.
existed in this area, was way smaller than the females.
Okay.
But what was weird is the females didn't really move that often. But
Okay.
what we found is during these wet season, these flooding events that would come in, the females would move massive distances. So
Okay.
they would it'd be like we had one that stayed underneath basically the same boulder for
Yeah.
2 months, never moved. And then all of a sudden it is a few kilometers downstream within a 24-hour period.
Yes.
We think it's to go to a nesting area. We're not entirely sure, but it'll do that. It'll go all the way downstream, and then a couple days later, it'll be right back at the same boulder it was at. It's just so
It's
incredible.
interesting. Thank you for sharing these. And so, let's move on to big data and biogeography.
Yeah, yeah.
So, what is big data and what tools do you use for big data analysis?
Yeah, so that's like so my current work is definitely more focused on like you mentioned, big data,
Yeah.
biogeography. And big data is just sort of that. It's a lot of data. We live in the age of big data where we just
Yes.
have we basically have the problem of having too much data and not entirely sure how to analyze it.
Yes.
So, for example, one of the data sets I work with is just occurrence records of species in Middle America. So, like
Okay.
Central America, parts of South America, parts of North America. And that raw data set is 1.3 million rows,
Wow.
and then 200 something columns. So it's just a stupid amount of data.
Yeah.
And what I'm trying to do with that is this biogeography study,
Yeah.
just sort of trying to infer regions of shared evolutionary history. And so I guess like the second part of the big data in my data set is the actual evolutionary history of the organisms. It's this massive phylogenetic tree, how are species related. And it's at most it's going to be 2,000 species, but it
Yes.
depends on how we filter it. So the tools we use though, they differ all the time now. Most of it is working in these coding environments, working with scripts, working with special programs. And a lot of the stuff that I do is really trying to focus on making big data for biogeography much, much, much easier to use.
Okay.
There's not great resources yet, and a lot of it is people having to make custom solutions because there's not great resources.
Uh huh.
And and everyone does it a little bit differently. And I'm like, let's make a cool package. Let's make some cool functions that make this so much easier to work with, because it's not easy to work with in the slightest.
Definitely. So as we talked about biogeography, what is biogeography and how is that linked to evolutionary biology?
Yeah, so it's funny because I did a presentation really recently for a course about the evolutionary methods in biogeography.
Okay.
Biogeography is a super old field. Like it goes back hundreds and hundreds of years, and at its core, it's the study of how and why species are distributed the way they are.
Yes.
That's like the core principle of it. But it wasn't until like the 60s and 70s that we really started to incorporate this evolutionary history. And the way we incorporate that is a lot of it is theory, because like a really basic set of that theory is like, if species are more closely related, they are more likely to be also they are more likely to have very similar distributions because they're more recently diverged.
Yeah.
But when we look into it more and more, what we start to see is how this change over time of their ranges. If they had a southward trajectory, if they were split by a mountainside, et cetera, we're starting to see how those forces actually create species. We're trying to see how incorporating this evolutionary history allows us to actually uncover regions that are so unique that we normally wouldn't see, because we're only looking at the species level. We treated all species the same, but that's not inherently true. Every species is a little bit different, and some are like critically endangered, some are not. And incorporating that in is just, that's what makes it so cool to me, because there's so many interesting analyses we can do. Like I have a lab mate who's trying to map basically the distribution of this family of snakes over time. And there's these really cool forces where it seemed like some of them came from South America, but some of them were also North America, but they kind of went back and forth and back and forth. So he's trying to figure out how that back and forth happened and how that actually made this family of snakes extremely diverse. So it's so cool.
It sounds really interesting. So so if we can simplify that for our audience, it's biology plus geography combined as biogeography. It sounds really interesting. If I was young enough, I would have taken this course right now because geography is one of my interests, and biologist. I am a biologist.
Oh yeah, biogeography is just such a cool field.
Yes. So are there any subclassifications or subfields in biogeography?
Yeah, there's quite a bit. So I think like right now we're kind of in a weird stage where everyone is doing these cool methods and like different things, but there's not really a great term to encapsulate all of it. So if you look into it, there's like conservation biogeography, right? Just like mapping how threatened species are, where they're at, where they're going to be. There's predictive biogeography. So you can make these really cool things called, I'll call them ecological niche models. They have different names, but it's essentially like you figure out where a species is currently, you know where it's at, and you make predictions based on where will the species be when the global temperature rises, where will the species be if we have like massive flooding events or a massive drought. And so you can predict it. And it's actually been used, I think, for COVID actually to predict where it could go with different temperatures.
Yes.
And then there's sort of the stuff that I get into, which is it doesn't have a great term because there's, for many reasons, but I think I'm going to just call it evolutionary biogeography and run with it because that hasn't been used yet. But yeah, it's just incorporating phylogenetic information, which is just how are species related to one another, into biogeography. And, you go into different methods within there and break it down more. Like every field, you can break it down more and more and more and more. But I'm gonna stick with those three main divisions.
No, that sounds really interesting. Thank you. So I know you are a very effective science communicator, and you are very active on Instagram, as we follow each other. So can you tell us about some of your strategies that you use for SciComm?
Yeah, science communication, I love doing it, and what I've been learning a lot more is how to, like you said, how to do it effectively.
Yes.
Because I've been doing it now for I want to say like 3-4 years, like intentionally doing it. I've always done education in some way, but it's like I want to do SciComm on Instagram or whatever. And I think like what's really helped me the most is just trying to be as authentic as possible. Like it's so tricky because I think a lot of scientists are there's like a implicit divide between scientists and the general public where we
Yes.
think we don't overlap as much, and I'm like, no, that's definitely not true. Like I know a lot about a very niche subject. Like
Yes.
you break me out of there, I'm completely lost. I'm clueless.
Yeah.
And so I just try to be very honest about that, but also like trying to be, I don't know, like very very real about things, right?
Okay.
I don't want to be sugarcoating, and I don't want to make it seem like science is perfect and everything we have here is absolutely brilliant and flawless, because that's not true, and that's not true
Yes.
of anything, you know. So yeah, being authentic, like aside from content strategies and posting frequencies and hashtag research and all that, just being authentic is by far the best thing that has ever helped me.
Okay. So as you talked about hashtags and content generation, so how often do you do it? How often do you post contents, and what are some of your favorite hashtags?
Yeah, it's oh gosh. So I used to post 3 times a week. That was
Okay.
my whole thing. And then at the start of this year, I challenged myself for a month to post twice a day.
Okay.
So massive jump.
Okay.
Yeah, but now I try to post at least 5 times a week. That's like my main thing.
Yeah.
But I think it's important to note that that doesn't mean the 5 same types of posts. So I have these questions that I do where it's I just pull
Yes.
up my phone and ask a question. Those I specifically designed those as a post that takes me less than 15 minutes to make.
Okay.
So because I will usually, like my last post, I did something about chytrid in frogs, which is this
Yes.
terrible thing of killing a bunch of frogs worldwide. That took me about 3 hours to make. You know, just
Yes.
just one post that's gonna live in the Instagram ecosystem for 24 hours.
Yes.
But yeah, in terms of the hashtags, I definitely vary it quite a bit depending on the post. I usually go for like I know, gosh, my general strategy is like 20% small hashtags that don't have that many posts in them. Like,
Yes.
I mean, not that many is like less than 50,000.
Yeah.
And then about making sure I get my percentages right. About 60% of them are between like 50 and 500,000, and then another 20% are over that.
Okay.
But there's some general ones I use. I almost always use Snap Wildlife if I'm posting a wildlife picture. I do a lot of herpetology pictures, science communicator, just stuff that like it's stuff that I want someone who is interested in these things to be interested in my posts. So I try to do that. But at the end of the day, I will say hashtags are focus on them way less. I don't think they help as much unless you're a massive account.
Okay.
And even then, like they barely help me. Like if you look at my insights, barely help me in the slightest. So
Okay.
yeah.
No, because what I've heard is like hashtags are the library. If you want to search a book in the library, you have to know you should know the name. So hashtags function like that. So that's what I
Right.
think, and that's why I also use a lot of hashtags. At least the whole 30 that
Yeah,
Instagram
it's
allows.
all of them. I think well, and like you're absolutely right. Hashtags help people find you.
Yeah.
But it's tricky because there's over 1 billion users on Instagram.
Yes.
And that's the thing. You're competing with these hashtags with 1 billion other people. So it's super tough. So like I usually do like maybe a week out of every month where I just don't use any hashtags. And
Yeah.
it's kind of more just mentally freeing to not worry about them for a while.
Yes.
And I find that my posts don't do that different, but that's also like I think they help more when you're in that like major account, and like that's where you're really hitting big. But it's tricky. It's super tricky, and yeah, sometimes I get good hashtag stuff, but I also try to rely more on getting people to share my content, getting people to
Yes.
comment and tag people. That's what I think gets way more traction. Just
Yes.
making stuff that people want to send to their friends. That 100% will help you more than
Definitely.
spending an hour on hashtag research for every
Definitely,
post,
no.
which is what I've done. So
No, as you mentioned about your frog post, which you mentioned on your stories, or I think I remember on your stories, it took you 3 hours. So,
Yep.
do you think one should spend like 3 hours on making a post, or was that a very special post?
I will say no. I usually my general rule for a general post is it should not take me more than an hour
Yes.
from starting the post to posting it. Which,
Okay.
like, yeah, it is an hour. Like, that does take time, but it's because I want my stuff to be well researched. I want it to make sure it's actually good. Um, but I like making. I, I guess if we break down like my average content for a week, right? I
Yes.
have 2 to 3 posts that take about an hour to make. I have 2 to 3 posts that take about 15 minutes to make. And then I usually have one post, this maybe sometimes two, that take me like 2, 3 hours to make.
Okay.
And that's partially for my own sanity,
Mm-hmm.
just because if I'm spending 3 hours on every post, this is a full-time job. That's I guess part-time, whatever, but that's like 20 hours a week minimum just making the
Yes.
content. That doesn't even include responding to comments, figuring out how to promote it properly, commenting on other people's stuff, and building a community.
Yes.
But I think building that community is way more important. Like, if I would much rather spend 15 minutes on every post I make and then spend instead 2 hours just talking to people and commenting on their stuff. I think that's way more fun,
Yes.
but also just better as like a science communicator.
Yeah.
You need to have a community to communicate.
Of
That's
course.
how I see it.
Definitely, community is really important. So, what do you think is the best or most effective platform for SciComm right now?
So that's something that I've always had such a hard time with,
Uh huh.
right? So, and I think that's because SciComm is really diverse. Like, I talk about this with a few friends quite a bit,
Mm-hmm.
that there are many different types of science communicators.
Yes.
So, like, if I define myself, I'm more of a science educator. I really like to take things that I might have some information about
Mm-hmm.
and learn more and then educate. But there's also a whole other side of science communication that is sharing articles. That is,
Yes.
yeah, sharing articles, sharing research, sharing blog posts. And for that, absolutely, Twitter is the best spot for that type of psychon. Like, sharing stuff, 100% Twitter. There's amazing things there.
Yes.
When it comes to the education, I get really torn between Instagram and YouTube, because YouTube has amazing content for educating. Like, there's so many big channels that do that, but I also think it's way, way, way harder for a starting science communicator to do YouTube. There's so
Yes.
much that goes into it, and it's difficult. Instagram is in a weird spot for me because there's not as many science educators. I would say there's a lot of sharing stuff. There's a lot of I call it SciComm for SciComm.
Yes.
It's people who are sharing SciComm tips for science communicators, and there's a lot of that on Instagram. So if your whole thing is that, absolutely doing that. If you're sharing other people's content and like building it up, Instagram is also great for that.
Mm-hmm.
Um, but in terms of the education, I think it's been underutilized on Instagram quite a bit,
Yeah.
because a lot of the times, which is something that I've done for years, and I'm not doing it anymore, but it's putting all the information in the caption. People don't read. Like, I'm realizing that more and more, they won't read your caption. But if you translate that into like nifty little videos, cool carousel posts where you have to swipe through
Yes.
10 different things that have like that, people will absolutely eat that up on Instagram. It's just designed for that.
Uh huh.
And that's where I think I mean, I'm biased, of course. I love Instagram. That's what I like doing my stuff on. But yeah, I think that every platform has their own pros and cons. And
Yeah.
something I'm really doing more is trying to do more live streams and stuff. Instagram is not the place for that. It has live. I don't think it's the best spot for it. It's great for just hopping on a call and talking to someone. But I think YouTube is a great spot for that. Twitch is also really good. There's some
Okay.
incredible nature enthusiasts that I follow on Twitch. And there's a couple other like smaller platforms that are becoming up more. Like, I work with Mammals, which is a nature focused social media app that is in like a beta stage right now.
Yeah.
So there's a lot of different places for it.
I see. Interesting. So, what do you recommend to people who are just starting into SciComm?
Yeah, for people just starting, focus on finding a community. Like, that's something I neglected for a long time, and it's it's one important just to have a audience that you can connect with and talk to, but it's also so important for keeping your morale up.
Hmm.
When you have this, like, even if it's only 10 people that like your posts and are really like engaged with it, those 10 people are kind of who you start making the posts for, and you get really appreciative. They're really supportive. They send you a message like, I really like this, they comment or whatnot. And creating that community is something that I've been really trying to focus on very heavily the past few months. And I'll say, like, my enthusiasm, my morale, my everything with SciComm has improved dramatically because of the community.
Okay.
And what you'll find is, like, I think the biggest sticking point for new SciCommers is growth, which is absolutely true. Growth is,
Yes.
It's hard to make content and not see new follows, not see new people coming in. But when you have that community, they're sharing your post to someone else, and then that new person will follow you, and then they're part of your community, and then they're sharing it, et cetera, et cetera. So absolutely, you can figure out the top strategies, you can figure out the hashtags, you can figure out how to make your content look beautiful.
Mm-hmm.
But if you don't work on that community, it doesn't matter at the end of the day.
So, great. Thank you for sharing all your little bit secrets with us today. It was really a pleasure talking to you.